Loudness, normal hearing. If you have a 20 dBs change in level is 4 times louder, as we told, because every time you change 10 dBs is a double in loudness. So yeah. So what impair? How about the hearing impaired listener? Yeah, you can say you can see the line here. Yeah, up to slope is fast up to 60 dBs. Under 60, less than 60 dBs loudness level, the hearing impaired listener has problems. Yeah, normal threshold curve is a green one. Yeah, Stevens power law you can say is I remember a formula from it. The loudness n is 2 up raised to the L minus 40 divided by 10. L is the sound pressure level, or loudness level. So it gives sense about the curves. Loudness hearing loss. Normal listener, 20 dBs change in level is 4 times louder, as told before. Hearing impaired listener, 20 dBs change is 20 times louder if you go from 40 dBs to 60 dBs. Then it is 20 times louder. It goes from you can see when the loudness level is more than 60 decibels, a normal listener and a hearing impaired listener will follow the same rule. The same increases after 60 dBs for both normal hearing listeners and hearing impaired listeners will the loudness will increase in the same way. Loudness recruitment? That means loudness grows much faster compared to normal hearing listeners. Smaller dynamic range in hearing impaired listeners. Yeah, you can. Yes. Okay. Yeah. Yeah. Ips. Loudness. Loudness and duration. Loudness depends on intensity, sound intensity and frequency. How does it depend on time? Are shorter or longer sounds at the same time more or less loud? In this experiment, the noise level of a noise signal decreases in 8 steps for several signal durations. Count the number of steps you can hear in each case. So the duration is from 300, 100, 30, 10, 3, and 1 milliseconds for the signals. Yeah. And it shows up the temporal integration. Paulson from 1981. Loudness comparisons of tone pulses of different durations. 25 subjects. For loudness, equal loudness, 5 milliseconds tones needs 17 dBs higher level than 640 milliseconds tone. You can say here, you can see it on the graph at the right. For instance, if you have a 55 dB loudness, then and 640 milliseconds, the sound pressure level is a little bit, maybe 55. Yes, 55 dBs at 640 milliseconds. And at 5 milliseconds, it has to be 72. So, yes. So, almost for each loudness, it could be 35, 55, 75 dBs, 95 dBs at 640 milliseconds. If you need the same, if you want to hear The sound pressure level has to raise about 17 dBs after only 5 milliseconds. Yeah, for equal loudness. For equal loudness. Yeah, the loudness is the same. Yeah. Loudness curve. So you can say you have a loudness for a long tone, and following the power law, and then you have a modified power law where for normal listeners where the loudness level starts at 0, and then after 20 dBs is a straight line slope, the same slope as the loudness for a long tone. And if you compare 640 milliseconds, yeah, okay, then you have the 640 milliseconds is about 3, starts at about 3 loudness level 3 phones, and same shape as that for the modified power law. And then you have 5 milliseconds, start about 20 dBs and have the same shape as the 640 milliseconds, but you have to increase this loudness level about 17 dBs from when you go to have the same loudness in zones. If you go from 640 milliseconds duration to 5 milliseconds duration, you need more decibels to get the same loudness. Yeah. Yes. Sum up. Psychophysics. Mapping between stimulus and response. Absolute versus thresholds. Weber fraction. Delta I divided by I equal to a constant. And Stevens power law. P is I divided I 0 raised to E, exponential E. It could be in 0.3. Yeah. Yes. And loudness, P is a perception, and I is the intensity. Loudness, perception scale in zone. Loudness is a perceptual scale in zones. Loudness level is relative to reference in phones. It means equal loudness contours. Loudness requirement and temporal integration of loudness. That was part 2. Thank you.